Okay, so if we want to look at this, one thing you might notice on number 2, part I, is that this looks an awful lot like the definition of derivative. And in fact, it is. Our function, f of x, is cosine of x. But it's plugged in, the point pi over 2 is what's plugged into that function. So we want to evaluate it at So you could spend time computing this limit, but I think you're going to be wasting your time. Probably you can do it a lot faster if you just know that f prime of x is negative sine of x. And you want to look at f prime of pi over 2. So if you plug that in, negative sine of pi over 2 is negative 1. The answer is C. If f of x is 5 to the x, then the fourth derivative is what? So if we think of f of x as 5 to the x, the derivative of that f prime of x is 5 to the x natural log of 5. And if you think about it, every time I take a derivative, I'm going to be bumping on, or adding on, not adding on, multiplying on another factor of natural log of 5. So f double prime of x, I'm going to have 5 to the x natural log 5. And then that natural log 5 is still multiplied there. So I have natural log 5 squared. And I'm going to take the third derivative, I'll have natural log 5 cubed. And the fourth derivative, I'll have natural log 5 to the fourth. So the answer is D there. For this function, I want to use the product rule and chain rule. So if I take the derivative of that, it's going to be the first times, the derivative of the first times the second, f of x squared, plus the first function, which is just x, times the derivative of the second. And I have to use chain rule here. It's f prime of x squared times the derivative of the inside, which is 2x. And so if you look at these answers, I think A, it's a little bit rearranged from what I have. They put those x's together, but that's the same thing. The next one, I want the equation of the tangent line to the graph of f of x when x is sine x when x is pi over 6. So the two things I need is I need a point on the line. So I already have an x-coordinate. I need to find a y-coordinate by plugging it in. I get y is equal to sine of pi over 6, which is 1/2. So my point on my line is pi over 6 and 1/2. So this is my point on my line. Then I need a slope. I can find the slope by using the derivative. F prime of x is cosine x. And if I take f prime at our point that we're evaluating at, pi over 6, that gives me this slope when the x value is pi over 6, which is root 3 over 2. And so I have a point, I have a slope. This is my m. And so I can do y minus y1 equals m times x minus x1. So y minus 1 minus 1/2 equals m, which is root 3 over 2, x minus pi over 6. So let's look and see what one works. It looks like this one is the same thing, just a little bit rearranged, but there it is. Okay, next page. I have a rock is thrown into a pond creating a circular ripple. I want to do the relationship between the rate of change of the radius with respect to area. So first of all, I need to relate the radius and area. I know the area is equal to pi r squared. And then I can take the derivative of both sides with respect to t. So dA dt is equal to, now remember pi is just a constant, so it's just going to stay there. The derivative of r squared is 2r, and then I need to multiply by the derivative of the inside function, the r itself, which is dr dt, because I'm taking the derivative again with respect to t. So if I look at what I have here for options, it looks like this one matches up most closely with what I have there. I'd rearranged a little bit, but yeah. Okay, on number 2, I have the linear function L is tangent to the graph of that function. Then it says, suppose the slope of L is 1/2. Okay, so I know the slope is going to be equivalent to the derivative. So first let's take the derivative, f prime of x. So the first thing I want to do is I want to think of f of x and just rewrite it to x plus 2 to the 1/2. And that'll help me take the derivative a little bit easier. So again, it's a chain rule. So I'll have 1/2 x plus 2 to the negative 1/2 times the derivative of the inside function. Well, the derivative of x plus 2 is just 1. So there's that. So I know that derivative needs to be equal to the slope of the tangent line, which is 1/2. So if I set that equal to 1/2, I can multiply both sides by 2. I can take both sides to the -2 power, which will undo that power. 1 to the -2 is just 1. And then I can add that 2 over, or sorry, subtract the 2 over. So I get -1 equals x. And then to find the y-coordinate that corresponds, I can plug it into my function. F of -1 is equal to square root of -1 plus 2, which is square root of 1, which is 1. So if I think about this, this makes sense, because what do we have here? We have a square root of x function that's shifted to the left 2 units, and so it looks like that, and I know that it goes to the point -1, 1, and then that line there has slope of 1/2. So my point there is -1, 1.